Today in class we looked at what happens when we reflect a line or a parabola in the coordinate plane, okay? So below are the rules that we have already learned. These rules tell us what we do to the coordinates when we reflect something in the x-axis. We multiply the y-coordinate by -1. When we reflect something in the y-axis, we multiply the x-coordinate by -1. When we reflect something in the origin, we multiply both coordinates by -1. And when we reflect something over the line y equals x, we switch the two coordinates. So first we reviewed lines of symmetry. Lines of symmetry are the line that you can draw on an item, where if you were to fold the item in half, both sides would match up completely, right? It would look something like this. So that is a line of symmetry. Let's look at numbers. 0 would have two lines of symmetry. One, it's kind of hard to match the stylus up with the figure, so 0 would have one here and one like this. 1 would not have one, 2 would not have one, 3 would have a line of symmetry across the middle like this. 4 would not have one, 5 would not have one, 6, 7 would not have one. 8 would have two, one here, 9 would not have one, and 10 would not have one. So we have 2 here, 1 here, and 2 here. And we're referring to the lines of symmetry. Now let's find the lines of symmetry for the letters of the alphabet. This one is kind of longer. We'll just go through the first few. A has one here, B has one here, C has one here, D has one here, E has one here, F does not have one, G does not have one, H has one here and one here, and one here. J does not have one, K has one here, L does not have one, M has one here, N does not have one. O has an infinity because it's a circle. So you can use any diameter in order to cut it into a line of symmetry, okay? And then so on and so forth. Let's do our first example. So this question says, draw the line y equals 2x plus 1. So we're going to take our x values over here and plug them into the equation, and we will get y equals 2 times -2 plus 1. Just do this in your head. It's easier than doing it on a calculator, right? So we have -4 plus 1 gives us -3, -1. We get -2 plus 1, which gives us -1. 0 times 2 gives us 0 plus 1 gives us +1. 2 times 1 gives us 2 plus 1 gives us 3. 2 times 2 gives us 4 plus 1 gives us 5. Gives us 5. So let's plot our points. We're going to plot these points on the graph, okay? So we have -2, -3. Then we have -1, -1. Then we have 0, 1, 1, 3, and 2, 5. Connect our points. Label our line. This is y equals 2x plus 1. And now, if we are reflecting, the question asks us to reflect, this part got cut off, but the question is asking us, okay, they tell us to reflect it in the x-axis. So remember when we were reflecting shapes over an axis, we find the x-axis, the x-axis is the boss, right? And we counted the distance from the point to the boss and then replicated that distance on the other side. So if we did that here, we would count 1 unit to the boss, 1 unit over, that would be our new point. Here we would count 1, 2, 3 units, 1, 2, 3 units, that would be our new point. Here we would do 1, 2, 3 units, 1, 2, 3, that would be our new point. Here we would do 1, 2, 3, 4, 5 units, 1, 2, 3, 4, 5 units, that would be our new point, okay? So just so we can see our new line, I'm going to make our new points in red. Okay, and our new line would look something like this. So look at our new line. Is the slope positive or negative? The slope is going to be negative slope, right? Because the line is sloping down. Remember Mr. Slope Guy? This is a positive slope, this is a negative slope, this is an undefined slope, this is a zero slope. Mr. Slope Guy, right? So if we know that the equation of the new line, let's clean it up a little bit, right? The equation of the new line has a negative slope. It's going to be negative 2. So what is the y-intercept going to be? Where does this line cross the y-axis? At negative 1. So now it's going to be negative 2x minus 1. Where does the original equation cross the y-axis? At positive 1. And it says so in the equation. So now the equation of the new line is going to be y prime equals negative 2x minus 1. What is the connection between slope and y-intercept? When we reflect over the x-axis, slope changes and the y-intercept changes. Let's do this one quickly, okay? So we have the line y equals 2x minus 2. So if we substitute x value into the equation, we get negative 2 times 2 gives us negative 4, minus 2 gives us negative 6, okay? Next, we have 2 times negative 1 gives us negative 2, minus 2 gives us negative 4. 0 times 2 gives us 0, minus 2 gives us negative 2. 1 times 2 minus 2 gives us 0. And 2 times 2 is 4, minus 2 is 2. So let's graph these points over here. Negative 2, negative 6, negative 1, negative 4, 0, negative 2, 1 over 0 up, 2 over 2 up. Okay, so here is our line. And we're going to label it with the equation y equals 2x minus 2. So this is our original equation. Now, instead of doing the counting method, let's do it the method where we multiply the coordinates, right? So the question says to reflect the line in the y-axis. Remember, when we reflect something in the y-axis, y is the boss, x is the employee. X is going to change, y will remain the same. So let's set up a new quick table. We are reflecting in the y-axis, so we will be multiplying all of the x coordinates by negative 1 and putting the new values here. So now we will have positive 2, positive 1, 0, negative 1, negative 2. And our y values are going to remain the same. Okay? Okay, so let's plot our new points. We have 2, negative 6. We have 1, negative 4. We have 0, negative 2. We have negative 1, 0. We have negative 2, 2. Okay, so here's our new line. And let's look at the slope here. The slope on this line is going to be negative. And the slope is going to be negative 2x, therefore, of y prime. Now, where does this new line here cross the y-axis? At negative 2. So the equation of the new line is going to be y prime equals negative 2x minus 2. What is the connection between the slope and the y-intercept? Does the slope change? Yes, the slope changes. Does the y-intercept change? No, the y-intercept stays the same. And we'll do one more example. Draw the function y equals x squared in the graph. Does the reflection of this function, draw the reflection of this function in the x-axis. Okay. So first, we're going to find the values of y given the values of x. So we have y equals negative 2 squared. Y equals negative 1 squared. Y equals 0 squared. Y equals 1 squared. Y equals 2 squared. And this becomes positive 4, 1, 0, 1, positive 4. Okay? These are our y coordinates. Let's graph them. We get negative 2. We get negative 1, 1, 0, 0, 1, 1, 2, 4. And we have a parabola. How do we know it's a parabola? Because this is the equation of a parabola, so it makes perfect sense. Let's label our parabola. Okay? So now we have to reflect this parabola in the x-axis, because that's what the problem says, right? So let's make our new chart. We have x prime, y prime. Who's the boss here? X is the boss. So therefore, x will not be changing, y is going to change. So our x values are remaining the same. We have negative 2, negative 1, 0, 1, 2. And our y values are going to be multiplied by negative 1. And we are going to get negative 4, negative 1, 0, negative 1, negative 4. And we get Here we go. So this is our reflection in the x-axis. Now, the question asks us, what is the function of the new graph? When they ask us for the function, they're asking us for the equation, right? Well, let's look at this algebraically. In order to change the original function y equals x squared into a reflection over the x-axis, we multiplied all of the y coordinates by negative 1. So what if we multiplied the y in the equation by negative 1? We would get negative y equals x squared. Now, have you ever seen the standard form of a parabola that looks like this? No. You have to divide both sides by negative 1, and you get y equals negative x squared. And that is the equation of the reflection in the x-axis. Now let's draw the reflection of this function in the y-axis. Okay, now y is the boss. Y is the boss. That means x has got to change. So x is going to change now. What happens, though, if we multiply all of these x values by negative 1? Well, this is going to turn into a positive 2. This is going to turn into a positive 1. This is going to turn into 0. This is going to turn into negative 1. This is going to turn into negative 2. We're going to get the exact same values over here in y as the original, and I'll tell you why. Because 2 squared is 4. 1 squared is 1. 0 squared is 0. Negative 1 squared is 1. Negative 2 squared is 4. So I'm going to get the exact same points when I reflect this parabola over the y-axis. And that's because a parabola is symmetrical, and this axis is serving as the line of symmetry. Therefore, If we were to fold this parabola right here, this side would match up equally with this side. Therefore, the graph is not going to change and the function is going to remain y equals x squared. That's it.